Okay, I got back for the end of it. It still got a little ways to go, I guess, but you see a little different color right in here. And at first I thought it was because I had the RPMs up so high, that's why it's just shiny right there, up higher. I had the RPMs up to 8,000. So I thought maybe it kind of galled it up or something, but what it is I'm taking a 1/1000 step out in this direction, not in the direction of the radius. So as you come down the radius, coming out, a little bit of a step out is a longer step down. And that's why the top looks so good, because a little bit of a step out is an even shorter step down. So that part right there is just lines that you're seeing, like coarse lines. With hindsight, I probably should have just scanned back and forth like this. Damn it, cat. I'm gonna scratch this thing. Got a stupid cat playing around. Anyway, if I had gone back and forth, it would have been a consistent step over. It might have looked funnier. I don't know. But these coarse lines wouldn't be there. And I suspect as I come down this wall here, it's going to be like pretty big step down. It's going to be a coarse lines also. So another test would be just to do a scan and increment in that direction and just do back and forth. That's probably a better idea on when you've got a bigger radius like this. So it is a good proof that this machine can cut aluminum, though. There's no reason why I can't do some aluminum work. And I suppose I could have gone faster, but I'll leave it consistent. It's 10 inches a minute. And when you're in a small, right in the middle of the circle, like this is just cutting in a circle and it's going further and further out. So when it's in the center, it looks like it's going really fast. But as it gets further out, it looks like it's going slower and slower. Looking pretty good so far, though. Definitely satisfactory. Yeah, it finally looks like it's starting to head down that wall. Yeah, it's starting to do like a plunging action because that wall is it's 5 degrees. So whatever 1,000th is, let's see, 5 degrees tangent. Hang on a second. 5 degrees tangent times 0.0015. Well, that's the wrong direction. Let's see here. Let's see, we're looking at 5 degrees here, and we're looking at 1.5 there. So 5 degrees tangent is equal to opposite, which is about 1,000th, over the adjacent. So x, if you pull that over here, the 5 tangent will come down over here, so it'll be 0.0015 divided by 5 tangent. 0.0015, yeah, 0.0015 divided by 5 tangent equals. See, it's moving down 17 thousandths. Every time it comes out 1,000th, it moves down 17. So it's going to be a lot coarser. Yeah, you can see the lines. But that's all right. You know, it's just something that you got to pay attention to. Like I said, if I had scanned it this way, I guess in this position here, it still would move up. Like, and when it comes out the other side, in this part of the circle, it would go down 17 thousandths. Even though in this position, it would only show a 1.5 thousandth increment. So you're gonna have pros and cons no matter what you do. It looks like, but you have a smaller area. That's going to be a problem. It'll be just this, like in this area here, where this coarseness is. It'll be just in this area, right here in this front part. It'll be less and less as you go back. So you could minimize the coarseness. I think we're getting close. We might as well just continue, and when it gets done, I'll blow it off with some air and turn the machine off so you can hear me, and take it apart and see what it looks like up close. I'll give you a zoom action here. It'll be a little shaky in my hands, but there's the machine. I have this is for my 3-phase. Well, it's 240 single that gets the VFD turns it into 3-phase, and this is my regular 120 stuff. And this will turn my spindle forwards and reverse. Alright, anyway, here. Let's see what we got going here. You might be able to see some lines there on that wall. It, like I said, it's a little coarser. But, you know, really with aluminum, it wouldn't be hard to polish out either. I think we're getting close. Okay. That's the close-up. Put this back on the tripod. Got a stupid cat in here. Keeps getting into stuff. Gonna get himself hurt, probably. Hoping all this noise would keep him away. You know what? I'm just gonna stop it. I've had enough of it. Close enough to done. So I'm gonna hold, stop. That's good enough. Okay. Let me get the airline. Clean this off. First I'll shut down the machine because that takes a minute. Turn off the computer. Let me get the airline, clean it up a little bit. We'll bring it up close enough to see what's going on. I put the plastic under it to be sort of a splash guard, a little protection of the. That's the machine shutting off. That's a little quieter. Anyway, I put this plastic on there because I was spraying WD-40 on it. Okay, let's bring it up here. Let's see. Hope you can see. Didn't do too bad. Like I said, it came down this wall at 5 degrees. So it's coming out a thousandth and a half, and it's going down 17 thousandths. So, you know, that's going to look a little coarser there. Same at this part of the radius of that 10 millimeter boss there, or dome, whatever you want to call it. It's jumping pretty fast as you're coming out in this area. You know, it starts. 1 thousandth and a half is a lot further down, so that's why there's some coarseness right there. So it's a good thing I did a really tiny step. Otherwise, it would be, you know, I thought I might do 3 thousandths or even 4 thousandths step, because 3 is it's not a bad finish, 3 thousandth step, but it would have made, you know, almost a 50 thousandth step. Well, it would have been about 50 thousandths, yeah. On this out here anyway. So that's what we got. It's a proof of concept that this machine can cut aluminum. It didn't seem to have any problem really. I roughed it out with a 3/16 and then roughed it again with an 1/8 inch flat, and then finished it with an 1/8 inch ball. I did rough it once with the 1/8 inch ball too. So there it is. No problem.